In this video, I wanted to review some basic math behind percentages and how to make sure to apply formulas correctly and the idea behind percentages and how they factor into things. And basically, just to review, percent means per 100. And basically, say you have 35%, that literally translates to 35 per 100 or divided by 100. So like the value of a percentage, you can always figure out, well, it's typically a decimal value or a fractional value because it's implied to be out of 100, but you often want to change it to its decimal form within a mathematical formula just to make sure that you're using the correct value of the quantity. So say, for example, you wanted to take 35% of 42. You'd want to take that percentage, add decimal form, and multiply by 42 to correctly get that, which would leave us with 14.7. And that's how you solve most basic percentage problems. And there's another term which is not exactly the same, which is what's referred to as percent increase or percent decrease, which is a little bit more complicated because it refers to not just the change in percentage. Percentages are always multiplied into things based on how they're calculated. But percent increase is basically you're taking a percentage of something and then adding it to it. Or percent decrease means taking a percent and then subtracting it to it. And if you're ever confused by those terms and calculating them, I found these formulas to be quite helpful in calculating them. So for example, let's look at these questions. It says your television provider increased the number of channels that you get from 167 to 213. Find the percent increase. And now typically percentages are ratios. So what you might be thinking is, well, do I divide them or what do I do, to get those? But if we look at what percent increase is, it says the amount of increase divided by the original amount. It's basically a ratio of how much did it go up by to how much I originally had. And basically, in order to do this, you first need to figure out what's the difference in the number of channels from start to finish. So the difference here, which I'm just going to use my calculator because I haven't done basic math in a while and I don't want to mess up these things by doing it in my head, is 46 is the amount of increase in channels. So if I was trying to figure out what's my percent increase, that'd be equal to 46 divided by the original amount, 167. And that, if I were to divide that my calculator, would leave me with a decimal value of approximately 0.2754. Again, that is a percentage, but it's not in percent form, it's in decimal form. So oftentimes we would then change it to percent form by moving the decimal place twice or multiplying by 100 and then writing the percent at the end. Because that's how percentages are often stated in real world, as percent form, just as a very common way of understanding a value that's less than 100. If you've ever wondered, well, why do we express it in different ways? It's just to make it a little bit easier to understand. But basically, you could say about 27 or 28 out of 100 is the percent increase. And basically, if you're ever wondering, what does this number mean and how do I really understand what percent increase does? If you were to apply this percentage to the original and then add it, it would give you, basically this is the amount you've grown from the original. So basically if I take my original amount of channels and I multiply it into that percentage, now I would want to make sure to multiply it by its decimal form, not its fraction. And I'm going to use a little bit more decimal accuracy to make sure it's closer. I'll just go ahead and use the full number. But basically, if I multiply the percentage, and percentages are always multiplied into things, they're never added, in their basic form, just because of the way they're set up. Notice that would give me 46. So this is the percent increase. If I multiply the percent by the original, it returns me how many did I grow, and then if I add that to my original channels, it gives me my new number. So that's the percentage that it's increased from the original, and it's a multiplicative number where I multiply it into it to give me the new amount. And the same goes for percent decrease. If you multiply the percent decrease into something, it should tell you how much is it shrinking by, or let's look at number 2. It says in 2008 you bought your Mustang for $30,000. It is now valued at $9,000. Find the percent decrease. So again, first we want to know, well, what is the amount of decrease, which is the difference between the two starting and ending values, which would be $21,000. So, and again, the percent decrease is equal to the amount of decrease, 21,000, divided by the original amount, which was 30,000. And I could do this without a calculator, and all the zeros were canceled, but let's just go ahead and type it in. That would give us 0.7, which would be equal to exactly 70%. And so that would be my percent decrease, which again, that gives me a number which, if multiplied into the original value of the car, it will tell me how much has been decreased. That's the percentage decrease. It's lost that much money. And again, you could use that information. But percentage decrease and increase can sometimes be a confusing idea if we don't know what that means. And that's why it's important. And this also emphasizes the importance of decimals. When you're dealing with percentages, we often express them in this form, but whenever we're doing math with percentages, they always need to be plugged in as a decimal. Like for example, say you have 5% interest rate on an account. You would always most of the time, you would almost always plug that into a formula as 0.05, not 5. And not changing it to its decimal form is bad because the decimal form is the real value of the number in the formula for the rate. And changing it to a percentage is just kind of changing it to the way we write percentages. Anyways, that is it for this one.